Welcome to our automotive electric series that we're going to be going through over the next couple of weeks. Our primary objective here is to teach you Ohm's law and how to utilize the formulas there to be able to calculate voltage, current, and resistance and how they're interrelated. But before we get into that sort of stuff, we need to make sure that you understand the basic ideas behind electrical theory. So we're going to spend a little bit of time in this episode going over voltage, current, resistance, and what exactly those mean, what they represent, what the symbols are for those, so that way when you actually start digging into the Ohm's law packets, you kind of understand what we're starting from. Okay. We're also talk about exactly what voltage is, how we measure current, and what is a resistance, or what could be leading to resistance in our current. We're also going to be talking about some basic wiring diagram symbols and how that's drawn and broken down for you. So let's go ahead and get started with our episode. So on the screen here, I'm going to be drawing real quick here a circle, and I'm going to break this circle down into 3 quadrants, which really doesn't make sense because quadrants is 4. All right, first top one here is going to be our V, and the bottom left is going to be I, and then our bottom right is R. Okay, so this is going to be something very similar that you guys are going to see throughout this series. So what does this exactly mean? Well, the first part here, or the first quadrant, is going to be voltage, as you can see. The I is going to end up being current, and the R here is going to mean resistance. Alright, and if we're going to talk about necessarily our symbols for this, voltage is going to have obviously a V, current is going to be measured in amps, so we're going to use A, and resistance is going to be measured in ohms, which is the Greek symbol for omega. Alright, so that's going to be kind of how that is broken down. Let's talk about formulas here for a second. So this circle represents the classic Ohm's law, V equals I times R. And this is kind of your baseline in regards to figuring out voltage, current, or resistance in a circuit. And all 3 of these are going to be interchangeable with one another. Okay, so what affects voltage is going to affect current and resistance, and vice versa throughout the formula. So as you can see on our little circle, V, we're trying to figure out V here, which means that I is going to be multiplied by R. So this line here dividing I and R is going to represent multiplication. Okay. Now we can also figure out I, or our current, by simply taking V and dividing it by R. So we obviously have our line up here. V's on top of R. That line is our division line. And same thing goes for our resistance. If we want to figure out resistance, it's voltage divided by our current. So those are the 3 formulas that we're going to be ending up using here in Ohm's law. Okay. So the main one that we're going to see most often is going to be V equals I times R. But it also depends on what we're calculating it for. Okay, so let's go ahead and talk about what exactly is V and I and R, and how that relates in our circuitry. Okay, so in order to understand this, I'm going to end up drawing something that you might be already familiar with, and that is going to end up being a water tower. Every city's got a water tower, and let's see here, there we go. Water towers typically sit up on a hill, and that leads down to a house, like so. I know. Pretty amazing drawing. I'm pretty impressed myself. Alright, then obviously in our water tower we have our water, like so. And let's go ahead and just, there we go, add a bunch of water to that. And that water tower has some piping, and it goes down and underground, and it comes over here, and then it comes up into your house. And when you turn on your faucet, the water pressure that is from that water tower is forced through those pipes and up out of your home. Okay, so we have a bunch of potential energy, and we're going to make that use. And the difference between the height of that water there and the height of water here, okay, this is going to end up being our pressure. And this is what causes water to come out of your pipes at home, if you didn't already know that. And obviously, the higher that water tower is, the greater the potential energy that we have for our water. Okay? So how does this relate to our battery? Well, if you think about it this way, let me see here. Let me go ahead and write on yellow. This water tower is representative in our electrical system as our battery. Okay, our battery is our voltage source for our electrical current. Okay, the water pipe here is representative of our wires in our circuit, and our house is going to end up being our load, because we can then use that water in our house in a variety of different ways to do different tasks. So that's going to be our work. Okay, so in this case, depending on how full our water is going to end up being in our water tower is how charged up our battery is. And the current is going to be flowing through here into our home. And we measure that flow with amps in an electrical current. Okay, I'm talking electrical here, not water. But electricity is stored in the battery. It flows through the electrical wire and then to our load. Okay, so this is going to end up being current. Now, if we want to increase our current, it's pretty straightforward. We could just simply come in here with a much larger pipe, right? And we could, or a much larger diameter pipe here, increase our flow because we have a larger tube to be able to do that with. Okay, and just like in your vehicle, we could have a larger diameter wire in our vehicle. You know, something that you might be familiar with is the wire that goes from your battery to your starter, or maybe you have a pretty decent sound system in your vehicle. You normally want a larger cable for that to be able to allow for more current flow in our system. Okay, and then obviously our resistance in our home is going to obviously depend on what we're doing. Do we just need a glass of water? Well, we're not probably going to have a super ton of resistance. If we're doing a dishwasher, maybe we're going to have that run longer, so on and so forth. This is an analogy. It's not perfect in that system to be able to explain stuff, okay? So, getting back to our original analogy here, the pressure here is going to end up being our voltage. Okay, so think of voltage as your electrical pressure. The current, measured in amps, is the rate at which the electrons flow in the wire, and the resistance is going to end up being how we create work for those electrons. Okay, and just like with everything, this is all cylindrical, or travels in a circle. Okay. All right. Let me go ahead and delete this, and we're going to get into some basic wiring diagram illustrations that you're going to start seeing here in a lot of the videos that we're going to be doing for Ohm's law. So think of it like this. We have a loop, right? And we already talked about a battery, so let me go ahead and draw a battery here. All right, so we know that we have a battery with two terminals. One is going to be negative and the other one's going to be positive. Alright, and on this particular battery, we're going to have a cable that's going to be, actually, let me do this quick. Here is our vehicle right here, or at least our chassis. Okay, I'll write that in here real quick. Car chassis. Okay, so with that being said, we have a cable that goes from our negative terminal on our battery and it hooks up down here to the car chassis. Okay, and then from there we have our positive cable, and that's going to come over here and connect to our car chassis as well. So now we have a loop, if you will. Okay, so real quick, depending on what theory you're working with, but the electrons can come in here, they come down here, they cycle back through here, and then back up to the battery. Okay, so let me go ahead and erase that quick, just so that way we have an understanding of our electrical loop. Oh, can I get this? Yes. Alright, good stuff. Now, within this electrical loop, we are going to have a load on it. And a load is going to be something maybe like a light bulb. Okay, so I'm going to draw this symbol here for a load. Let me go ahead and erase part of my wire here. Alright, so we're going to hook this up here, and our load is going to be a symbol that looks like that. Alright, again, not the greatest illustration, but it gives you an idea, okay? So we have a load, and a load could end up being anything from, let me write this on here. So we have a load, and a load could be a light, it could be a motor, it could be a whole bunch of different stuff on those ends, okay? Just note that the load is going to be what is going to be causing us to work. Alright, so this is kind of essential layout of our electrical diagram, okay? Now, in relationship to how it's drawn in real life, we actually have our battery, and our battery has 6 cells typically, so that's going to end up being drawn on here like so. Okay, again, not perfect, but it gets the idea. Okay, now we normally don't draw the car chassis in our electrical diagram, but we do illustrate that our ground is hooked up to the chassis through, there's a real quick symbol here, let me grab green, and it almost looks like it's an arrow pointing down, like so. Okay, and we're going to do the same thing over here. So let me erase this. There we go. Let's see, I'm going to grab red. And, alright. Okay. So this is getting more into what this actually looks like. You know what, let me just select this. It'll be much faster. There we go. We'll go ahead and delete that. Alright. So, getting back into labeling some stuff for you, we have our wires. Okay, that's a ground side wire. Let's see where we have wires over here. Consequently, this is also a ground side wire, but then we have a wire up here as well. And then we have our battery right here. And that is, again, our electrical source that we're going to use to be able to do all of our electrical work. So let me go ahead and actually draw what you would probably find on a diagram to begin with. Alright, let's start with our battery. So a battery in a wiring diagram does not have terminals on it. It just looks like this. Okay. Then this comes out as a wire, and then we have a load, and then it comes over here and ends to ground. And this as well. Okay, so again, this kind of gives you an idea of what you would probably more commonly see on a piece of paper. But all we're doing here is, I'm going to put this as well, breaking it down so it's a little easier to see and decode when we are actually working on a worksheet. Okay, and then obviously our wires are all over the place. We got a wire here, and we got a wire there, and then wire over there as well. Okay, so that kind of essentially breaks down our entire basics that you're going to need to know before actually going in and calculating Ohm's law. So what did we talk about today? Well, we talked about how voltage and current and resistance is all linked together and symbolized within Ohm's law, V equals I times R. And we talked about what voltage is, and current and resistance, and how it relates to our electrical system. And then we went in and drew our very simple beginning wiring diagram that contained a battery, it contained a load, and it contained some grounds with some wires. So hopefully picked up a few things there, so that way when we get into actually calculating with Ohm's law, things make more sense. So appreciate you guys tuning in. Again, if you have any questions, feel free to email me or ask those questions when we have a live stream. All right, catch you guys on the next episode.